Hi, I'm Bob Musano with Siemens Clamp-On Application Engineering. Today I'm going to do a deep dive for the FS230 liquid and gas signal analysis. To troubleshoot the FS230, especially for signal loss, you're going to want to make sure the meter is set up correctly first. We will log in as expert. I have mine set for all nines for ease of access. If you go down to security, you can change the expert pin or the user pin by following the wizard. To make sure that the meter has been set up correctly, follow the quick start, quick commissioning, sensor settings. You can skip units, pipe characteristics, and you're going to want to make sure that you've set in the correct outer pipe diameter and wall thickness. You'll want to make sure that you have selected the correct sensor size. You want to make sure that the medium characteristics are set correctly. And if you're dealing with natural gas, you want to calculate using the AGA table the correct sound speed. You'll also want to check that your path geometry is set up correctly. So we'll go into Configure Measurement Path. And in this case, the sensors are on the pipe in direct one traverse. If you're using a spacer bar, this will be your index. If you're using a tape measure, this will be your spacing in inches. Once you're finished with your path selection, you'll see a frequency sweep running. If it fails here, there will be a signal search message. Otherwise, it will advance to the receive signal screen, and you'll be able to see the signal as it appears to the meter. If, on the other hand, when you hit next, you end up with a signal search failed message, it means that something is wrong with the setup or the equipment. One of the more common reasons you'll have a signal search failure is due to a poor cable termination. On the transmitter end, you'll want to use the extraction tool for the cable. Slide it in. You might want to make sure that this has been tightened in all the way. And if you've found that both the up and down cables are completely tightened and you want to check the continuity, you can remove these cables, set your ohm meter to ohms, if you have slip-on connectors, measure from the outside of the slip-on to the center pin. This reads 280 ohms. Let's check the other one. And this reads open. There is a possibility that the slip-on connector is bad, so remove it. Check without the slip-on, and it still reads open. Okay, I've located the sensor which is reading in open. So I'm going to take this connector off. And this is a twist-on F connector. So I'm just going to twist it off. Now, upon closer examination, what I notice is that this braided material, by and large, is missing. Ordinarily, when this is stripped correctly, the material of the braiding should be up to the end of where you see this insulated part. So I'm going to snip this off. And I'm going to use this tool to re-strip it. And this is what we should actually see. The braided material reaching from the outer insulation just to the end of the inside insulation with no whiskers touching the center conductor. Just trim this piece of center plastic if it's still there. The length from the outer insulation to the end of the inner insulation is 1/4 inch, and from the end of the inside insulation to the end of the center conductor is 3/8. And then you just want to, well, first make sure no whiskers are touching the center conductor, and then just tighten this back on. The other possibility is on the other side of the board where the coaxial cables come in, there's a connector for path 1 and a connector for path 2. I've taken the digital sensor link, or DSL, out of another unit to show you, but there's this ribbon cable with a connector that has the potential of becoming loose. This would be the one for path 1. This would be the one for path 2. This can go and get plugged back in. And push down to make sure it seats properly. And you'll want to do this for whichever path is currently giving you an issue. If you happen upon the meter and you notice that the flow measurements have dashes, and the same thing for the other measurements, it means that there is some pending error. If we go down to view number 6, there is an error code and a description. And here's the description. I happen to notice that this cable came undone, so I will push it back in. Now you'll notice that our flow measurements have returned to normal since we have reestablished the sensor link. Now you can have the same error with this cable plugged in, because the problem could reside on the inside behind this foam. And this foam will pull right out. And you'll notice that this cable travels in this track and plugs in to this barrier cassette. Now, it's advisable to remove power, so I'm going to do that now. And I noticed that while taking the foam out, that the cassette came loose, or one of the cassettes came loose. This is something to consider, especially if the meter has been shipped and for some reason is giving you an error. You may want to remove the foam and check and reseat these cassettes. Now I'll explain what these cassettes are. This is the transmitter cassette, and this also has the functionality of either HART or Modbus. It has the cable where the LUI or the display is plugged into, and a small extension for the USB connection. So I'll plug this back in. This is the I/O cassette, and the functionality will vary based on the order code for the meter. I'll plug this one back in. And the last one is the barrier cassette. And this is what acts as isolation and protection between the outside world from the transmitter and the rest of the transmitter internally. And if you notice, the other end of this cable gets plugged in here at the top of the cassette. And you'll also want to check and make sure that this is not loose if you have that DSL error code that we saw. One other thing to mention is if you're trying to communicate with the meter using the service port via either FS200 tool or PDM, and you're not establishing a connection, you may want to reset this small extension cable, because on occasion it has known to come loose. And I'll also point out that the SD card plugs into this slot up at the top. If you ever need to replace the power supply, it is held on by 3 screws. There are 2 here, and there's one all the way in the back here. Once those screws are loosened and removed, this power supply will pop right out. So you should make sure that this connector is plugged in good. And as you recall, the other end of this piece is another short cable that goes into the top of the transmitter cassette. And you want to make sure that that end is plugged in correctly as well. In this case, the problem turned out that we have a bad local user interface. So what I'm going to do is replace that local user interface with a new one. So this particular part has the part number written right on it, as do the other parts that we were looking at internally earlier. In addition to view number 6, you can also go to Maintenance and Diagnostics. And there's a device status, which will tell you any pending errors. and there is a diagnostics log which shows you all of the past errors. Now, if you find that there's no issues with the coaxial cables, the ohming being incorrect, or the ribbon cable, there's also a possibility that you have an issue with the application. If we're talking about a liquid application, there could be excessive aeration. If we're talking about gas, there could be an excessive turbulence or not enough pressure inside the pipe. Whether you're using an air gap test for gas, a face-to-face test for liquid, or a pipe wall test using the half diameter of the pipe for liquid, if the equipment is working, you should see a signal something like this. On the liquid meter, under medium characteristics, make sure you choose the correct liquid. If it's just water, make sure it's the correct temperature range. If it is a finished hydrocarbon products, you can choose from one of the selections here, whether it's a crude oil or a liquid butane or a liquid propane. They are all right here. Natural gas liquid. If you're using a multi-product pipeline where it has kerosene, gasoline, jet fuel, you probably want to choose something that's somewhere in the middle. If you're unsure, what you could do is select one of them and then select a estimated sound speed of 1350, and that'll put you in a good position for most finished products. The reason why this is critical is because you want to make sure when you have a wide variety of products in the same pipeline that you don't run into one of the limits for sound speed. And the sound speed that you choose will also determine the spacing. So you can run into a situation where you have the sensors spaced either too close together or too far apart for a given liquid. And another possibility for liquid measurements only, if the sensors happen to be mounted on the pipe and reflect, what you can use is the half pipe diameter, program that in and switch to direct mount. And you can also check for the received signal. So as an example, if these two sensors were mounted on a pipe which was 4 inches in diameter, what you would do is reprogram the meter at 2 inches in diameter and switch from reflect to traverse to direct 1 traverse, and then look for the signal. To program for pipe wall test using the half diameter method, go into configure paths, select the path that you're working with, hit next. The sensors need to be on the pipe and reflect, but you're going to set the mount mode to direct mounting 1 traverse. Next. And provided that the equipment is working, you should see a receive signal, and this is the signal which is being passed from one sensor to the other via the pipe wall, which means that if you are unable to get a signal like this using the correct configuration where the signal would be traveling through the liquid, then and you had no signal in that instance, but you do have a signal using the pipe wall, that means that the problem is with the application and not with the hardware. We have another way to determine if the equipment is working or not, and that is either the face-to-face test for liquid or the air gap test for gas. Now, we have to program the meter appropriately for this to work. Now, if you're using the face-to-face method rather than the pipe wall method, and you can use the face-to-face method with steel or plastic or ductile iron or any pipe material, because this test doesn't involve the pipe at all. This is the test where we place the sensors face-to-face. You're going to enter in an outer pipe diameter based on a chart. And again, you're going to want to use the direct mounting mode when using face-to-face. And you should, again, get a workable receive signal like this. So the question is often asked, what is an acceptable signal numerically? Well, if you go from the main menu down to maintenance and diagnostics, and you find monitoring, you can go in here, find sensor, find the path of interest, and you'll notice that there is two gains, one for up and one for down, and two signal to noise ratios, one for up, one for down. Now, typically, we like to use 30 as a rule of thumb. For the gains, you'd like to see a number which is below 30. So in this case, 15 and 15 is good. The signal to noise ratio on this is a little bit low because the signal to noise ratio we like to see above 30. And that's true for both up and down. So for the gains, below 30. For the signal to noise ratio, above 30. The rule of thumb of 30 dB for the gain is true for liquids. For gas, because of the low density nature of gas, we would more expect a dB below maybe 40 to 45. So let's say 30 for liquids, 40 to 45 for gas. Signal to noise ratio for liquid and gas should be both comparable. Sound velocity is very important because sound velocity is a true measure of the meter's accuracy. If you know the expected sound velocity, and for water you can use temperature tables. For gases you can use AGA8 calculations. This will also tell you if the measured sound velocity is as expected. On this particular meter, what I've done on the main screen, view 2, I've already set up these readings so you do not have to go and look for them in Diagnostics. So, and they're by path. So for every path that the meter has, we have the same information. To set this up on your meter, go down to Local Display, pick a view that you don't mind dedicating for this purpose. In this case, I selected view 2. Make sure it's enabled and select 6 values. In here, you can set all your path 1, 2, 3, and 4, if you should have that many paths, for your gains, your signal to noise ratios, the speed of sound, and maybe the flow velocity. To get the accurate measurement of the diameter, take a tape measure or a pie tape and take the circumference. Now you can either enter this value in as a circumference, or you can take this number and divide by pi. To do a wall thickness test, get an ultrasonic wall thickness gauge. You have to use the coupling compound and take a measurement to get the most accurate wall thickness. And it's good to do this as an average over several places so that you have the best representation of the wall thickness. Also in the setup mode, under sensor is miscellaneous. In order to see miscellaneous in this menu, you need to be logged in as expert. Go into miscellaneous and find received signal averaging. For liquid, the default is 5. For gas, the default level is 8. Here's an example of when you may want to try increasing the received signal averaging. If you look at this image, there's a lot of baseline noise, and in this case, it's being caused by an upstream disturbance. Here's another situation where you may want to try increasing the received signal averaging. The random noise you see here at the baseline, sometimes we refer to this as asynchronous, will be lessened the higher the number we put for the received signal averaging. A situation where you might want to try lowering the received signal averaging is if the flows are surging forward, either for pulsating flow. Typically this is what you would see in gas and not liquid. And when the meter has a hard time latching onto the signal, sometimes a lower signal averaging will allow the meter to respond more quickly. Here's an example of a high Q signal. And a high Q signal is one in which it takes more than 5 cycles to reach the peak. And you see this is 10 or more cycles. And this is most likely an incorrect frequency match between the sensors and the pipe wall. This staircase wave illustrates also a mismatch, but most likely in this case, one sensor size was selected in the programming, but possibly a different size sensors are on the pipe, and you have this staircase wave formation. What you see at the baseline here is synchronous noise. The frequency which we're injecting into the pipe wall, which produces the fluid signal, is also ringing on the baseline leading up to the arrival of the fluid signal. This can either be caused by not applying the correct number of layers of dampening material, or CC129, or we could have a relatively poor wall thickness to pipe OD ratio, in which case if you're on reflect 2 traverse, switching to reflect 4 traverse may alleviate this. Or if you were mounted in direct 1 traverse, consider switching to direct 3 traverse. Okay, I hope you found this video helpful and informative. And if you have any other questions, please contact us at technical support.